Have you ever looked at the vast, seemingly endless stretches of sand and wondered why these incredibly arid places exist at all? These stark, dramatic landscapes, ranging from scorching hot to surprisingly frigid, are shaped by a fascinating interplay of atmospheric science and geography. Fundamentally, a desert is simply any region that receives extremely little precipitation throughout the entire calendar year, often less than 10 inches. The primary architect behind many of the world's largest deserts is the planet's massive, consistent global air circulation pattern, known as the Hadley cell. Imagine warm, moist air rising near the equator, creating lush tropical rainforests as it releases all of its much-needed moisture. Once that air cools high up in the atmosphere, it travels poleward, losing its heat, and beginning a slow, inevitable descent around 30 degrees latitude north and south. As this massive parcel of air sinks towards the surface, it compresses and warms up considerably, creating an intense, thirsty environment. This sinking air aggressively suppresses cloud formation because any rising moisture is immediately dried out, leading to persistently clear, sunny skies. Consequently, the world's most famous hot deserts, like the Sahara, are conveniently situated right along these natural bands of high atmospheric pressure. Moving beyond global patterns, local topography plays a surprisingly powerful role, especially when massive mountain ranges get in the way. This phenomenon, called the rain-shadow effect, demonstrates exactly how mountains can completely steal the ocean's life. Giving rain from one side, moist air moving inland from the sea is forced upward by the mountain barrier, causing it to cool and drop all its humidity as rain or snow on the windward slope. By the time that air mass crests the peak and begins descending the other side, it is incredibly dry, creating a stark, rain-starved desert leeward. Think of the Patagonia Desert in South America, perfectly situated in the rain shadow of the towering Andes Mountains to the west. Another crucial geographical factor determining aridity is the sheer distance from a major source of moisture. Like a vast ocean, areas deep within the interior of large continents, far from maritime influence, simply do not receive enough moisture to support substantial rainfall. By the time the humid winds reach these central continental interiors, the available atmospheric moisture has usually been completely depleted far earlier. This leads to the formation of continental deserts, stark landscapes that exist purely due to their isolated position on the landmass. Surprisingly, some deserts form right along the coastlines, even though they are directly adjacent to huge bodies of water, like the Pacific Ocean. These unique coastal deserts are created by the presence of powerful, cold ocean currents running parallel to the shorelines. Cold currents drastically cool the air immediately above the water, making it stable and preventing the necessary upward lift for thunderstorm development. The air remains cool and dense, resulting in persistent fog or low clouds, but it simply cannot rise high enough to condense into real, widespread rain. The famous Atacama Desert in Chile is the world's driest non-polar region, existing precisely because of this extremely cold offshore current. So, the existence of a desert is rarely due to just one reason, but is often a complex combination of these powerful global and local forces working together. It requires high pressure, mountain barriers, continental isolation, or cold ocean influence, all conspiring to keep the precious water molecules away. These seemingly barren environments, shaped by such fundamental forces, are vital ecosystems that support highly specialized and fascinating forms of life. Understanding why deserts exist reveals so much about the incredible dynamic balance that governs our planet's weather systems. From the dusty plains to the vast ice sheets, desert conditions are a beautiful testament to Earth's complex atmospheric machinery at work. Next time you see sweeping arid land, remember the invisible forces of sinking air and blocking mountains that made it that way. It's a reminder that even in absence, there is a powerful, underlying geological and meteorological reason for everything we see.